So continuing on, I've said that the body can recognize the antigens on pathogens, okay? So what does the body do once it recognizes that they have the antigens on the pathogens? All right, the antigens on pathogens, so not the antigens on your own cells, only the antigens on pathogens, will cause lymphocytes to produce antibodies. Okay, so you've got the word antibody, which is going to also be really important. So we were talking about antigens, and now we've got another word, antibodies. We are going to look at exactly what antibodies are, and for this I'm going to draw a few diagrams rather than writing out lots of information in words. So just do your best to draw these diagrams, although I'm not particularly artistic, so you should be able to draw what I'm drawing. All right, so I'm going to draw a pathogen, and rather than drawing it in any detail, I'm just going to draw it as a little oval, and to remind me that it's a pathogen and that it's not doing me any good, I'm going to put a little sad face. Okay, this is my pathogen, and on my pathogen I'm going to draw antigens on its surface. I'm going to draw the antigens as little arrows. They'll go all around the surface of my pathogen. Okay, so this is my pathogen. Okay, and around here on the pathogen I have got antigens. Okay, next to my pathogen I am going to draw myself a lymphocyte. So remember, lymphocyte is a type of white blood cell. I'm going to draw myself a lymphocyte. Your lymphocytes are going to fight those infections, so they're doing you a favor. So I'm going to put a smiley face in my lymphocyte. And on the surface of my lymphocyte, I am going to draw antibodies. You can see I'm drawing my antibody in a kind of a Y shape. So I've got antigens on my pathogen, but I've got antibodies on my lymphocyte. Right, I'm going to label this as a lymphocyte, which we remember is a type of white blood cell. Okay, so what happens is when you've got a pathogen inside your body, I told you each pathogen is going to have a different type of antigen. Okay, your body will recognize that you've got something in your body that's not supposed to be there. And that will cause lymphocytes, which are a type of white blood cell, to produce antibodies. And they produce these antibodies on the surface of their cells. Antigens come in all sorts of different shapes and sizes. And what the lymphocyte needs to do is it needs to produce an antibody which fits the antigen. So you'll notice here that when I drew the antigen, I drew it as an arrow. And then on the lymphocyte, when I drew the antibody, I drew it in a kind of Y shape. And the reason I did that is because the antigens on the pathogen will fit into the antibodies on the lymphocyte, just like a lock would fit into a key. Okay, these shapes, the antigen on the pathogen and the antibody on the lymphocyte, have to match. They have to be complementary to each other. And because pathogens come in, there's lots of different types of pathogens, each pathogen will have a different antigen, which means you need lots of different lymphocytes to be able to have the matching antibodies that are needed to fight the pathogen. So what's going to actually happen here? Okay, so in this case, I've specifically drawn a lymphocyte with an antibody that matches the antigens that I've got over here. Okay, but there'll be lots of different lymphocytes in your body, and they'll all have different antibodies on their surface. Okay, but if the antibody here on my lymphocyte, if the antibody matches the shape of the antigen, and in this case it does because I've drawn it that way, then the lymphocyte, which is your white blood cell, will bind to the pathogen. So I want to draw this out again underneath, okay? I can see that these antibodies and antigens match. So I'm going to draw my lymphocyte and I'm going to draw the antibody. Again, I'm drawing them like these kind of little Y shapes. And into my antibody, I'm going to draw my antigen that I had on my pathogen. So this is my pathogen. And I have got the antigens. Because the antigen on the pathogen fits the antibody on the lymphocyte, they will bind together. Okay? When they bind together, the pathogen will stop working. I know that sounds very generic. The pathogen stops working. How does the pathogen stop working? Okay, but if you remember, pathogens work in lots of different ways. So bacteria work in a different way to viruses, viruses work in a different way to protists, okay? They all work in different ways. So rather than looking at lots of different modes of action, we're just going to say that when the pathogens bind to the lymphocytes, the pathogens, they just stop working, okay? So the pathogen's not going to be able to work anymore. So whatever the pathogen was going to do, so just say the pathogen was a virus and it was planning to infect your cell and take over the DNA, the pathogen's not going to do that anymore. Just say your pathogen was a bacteria and it was going to produce lots of toxins to make you sick, it's not going to do that anymore. So it's just going to stop working. And what the lymphocyte is going to do is the lymphocyte itself is going to become activated. And when that lymphocyte becomes activated, it multiplies and it produces lots and lots and lots of replicas of itself, okay? Because you don't just have one pathogen in your body, you've got lots of them, okay? And this one lymphocyte by itself is not going to be able to bind to all of those pathogens. So as soon as a lymphocyte becomes activated, it just makes loads of copies of itself. So you've got lots of lymphocytes, all with the right antibodies, that can then go and bind to all of those pathogens and stop them working, okay? Another way that the lymphocyte can work, so we've seen in the picture above, the lymphocyte is binding to the pathogen. The lymphocyte can also, just produce loads of antibodies, and it will release these antibodies into the blood. So that you've got lots, because it's the antibody that's binding onto the pathogen and the antibody that's stopping the pathogen working. So the lymphocyte, it's quicker to release loads and loads and loads of antibodies, and they'll bind to the pathogens and they'll stop the pathogens working. So lymphocytes, as well as multiplying themselves and binding to pathogens, they also release large amounts of antibodies into your blood. Into the blood, okay? And these antibodies, again, once they're in the blood, they can stick to the pathogens and destroy them. And we're not going to go into how the antibodies work, because pathogens work in lots of different ways. The way the antibody will affect them will be different, okay? Just know that antibodies have to match, the shape has to match the antigen on the pathogen. If they do, the pathogen will bind onto the antibody. Okay, so in this case, the antibodies are attached to the lymphocyte, so they're binding on together. Okay, but you've also got situations where they just release lots of antibodies into the blood, and those antibodies will just surround the pathogen. Okay, as soon as the pathogen's antigens are bound onto antibodies, the pathogen's not going to work anymore. It's not going to be able to make you sick. Okay. So when the pathogen has been killed, because this response will lead to the death of the pathogen, so when the pathogen has been killed, that's a bean, killed, some lymphocytes, sorry, this is the last bit we're going to write. I know we've written lots in this video. This is very important. Some lymphocytes with the matching antibodies. Remember, different lymphocytes have different antibodies, okay? But once you've destroyed your pathogen, some of these lymphocytes that have the right antibody, they will remain in the blood. Will remain in the blood. Sorry, my writing's getting messier. When the pathogen has been killed, some lymphocytes with the matching antibody will remain in the blood. And we call these lymphocytes memory lymphocytes. Okay, why is this important? All right, we're going to draw a little graph, very rough sketch of a graph to show why this is important. Okay, so I'm going to draw a little graph, okay? And on my y-axis, I'm going to write antibody concentration in the blood. Okay, remember these are white blood cells, so you're going to find them in your blood. Antibody concentrations, how many antibodies do you have in the blood? Okay, and on the x-axis, I'm going to write days after infection. I'm going to start at day 0. I'm going to have 10, 20, 30, 40, let's go longer, 50, I just say 60. Okay, so day 0, okay, this is when you first become infected. Okay, so we're going to say we're getting infected here. You've just been infected. It takes quite a while for your body to start producing antibodies. So when you first get infected by this pathogen, you're not going to have any antibodies in your blood. And then slowly, after around, it can take up to around 10 days, the number of antibodies in your blood will start to rise. Okay? Then you'll have the antibodies in your blood. You've got lots of them in your blood. They're fighting the pathogens. They destroy the pathogens. And because you've destroyed the pathogens, you stop making these antibodies. The pathogen is gone and the level of antibodies start to fall. Okay. Now what you'll notice is that it never goes right back down to 0. Once you've had that antibody in your bloodstream, some of it will remain. So when it falls, it doesn't go right back down to where it was. And then you're carrying along and everything's fine. And then you get infected again, okay? The same pathogen enters your bloodstream again. But the second time you get infected, your response is a lot quicker. And you can produce a lot more antibodies a lot quicker. And then it will start to go down again. Okay, so we're going to label this graph. This is, I'm going to write, this is when you were infected. And it's taking around 10 days for your primary response to kick in. That's how long it's taking for your body to start producing antibodies after your first infection. Okay, so it's quite slow. It takes your body quite a long bit of time before it has the antibodies ready to fight those pathogens. Okay, your body beats the pathogen. Okay, the level of antibodies in your blood is reduced, and then just say here, we're going to say you're infected again. That same pathogen gets back into your bloodstream and you're infected for the second time, okay? But this time, because your body already has those antibodies in its system, it can reproduce them much, much quicker. And your secondary response is a lot faster. So your secondary response is after your second infection, and it's fast. You can respond really quickly. And the fact that you can respond so quickly is going to have a massive impact on how you feel, okay? Waiting these 10 days for your body to actually start fighting your pathogen, you're going to have a lot of symptoms and you're going to feel sick, okay? And then you'll still feel sick as the body is fighting, and it's not until you get over it that you'll start to feel better. If you've already got these pathogens in your body, the antibodies in your body, they'll be able to fight the pathogen so quickly that they will have fought it and destroyed it before you've even known you're infected. So you won't feel sick at all. So you've got some pathogens in particular that this is true for. So for example, the chickenpox. So most of you will be aware that you only get the chickenpox once, okay? The reason is because once you have the chickenpox once, you've got antibodies in your blood that will stay there forever, that know how to fight the chickenpox. So the second time you get infected by that chickenpox virus, because you've got those antis in your blood, they will fight the chickenpox virus so quickly that you won't even know it's in your system again. So the actual symptoms and the sickness of the chickenpox, you'll only feel once. You'll feel the first time you get infected because it takes your body a long time to fight it, and you'll feel the symptoms. The second time you get infected by the chickenpox virus, you've already got those lymphocytes, those memory lymphocytes that can produce the right antibodies. They kill the chickenpox virus straight away, and you don't even feel sick. Okay, so they're called memory lymphocytes. If you've been infected with something once, they will remain in your blood. They will enable you to fight it much, much quicker the second time. And you probably have heard quite a lot about antibodies lately because there's a lot of talk about them with the coronavirus. So you may have heard them talk about the antibodies test. So what that would be is they want to test people's blood to see if they have the coronavirus antibody. Because if you've got the antibody in your blood, it means that you have been infected by the coronavirus and your body has learned how to make the correct antibody to fight it. Even though you don't have the coronavirus in your system anymore, you still have the antibodies in your blood, which means if you get infected again, you'll be able to fight it a lot quicker. So if you have the antibodies in your bloodstream, it means that you must have had the disease before. So they're talking about trying to develop an antibody test because it will let them know how many people have had the disease. Okay, some people, when they got the disease, because they've got a good immune system, they fought it off really quickly and they didn't have symptoms, so they didn't even know that they had the disease. So by doing the antibody test, you'll be able to tell exactly who's had it and exactly who hasn't. They also believe, well, they don't know this, but they theorize that if you have the antibodies in your system, that could make you immune to the disease. Okay, because you've got the antibodies in your bloodstream, if you got infected by the coronavirus again, you'd be able to fight it so quickly that you wouldn't get sick, you wouldn't need to go to the hospital, then therefore you're not putting any strain on the NHS. Okay, but they don't know for sure. They don't know that just because you've had it once, you definitely won't get it again. Okay, they don't know. But they are theorizing that, if you've already got the antibodies in your system, you should be able to fight it quick enough that you're not going to get sick and you're not going to be at risk of dying. Okay, so they want to know how many people have these antibodies already in their system. Okay, so we have done quite a lot in today's lesson about the immune response. In the next lesson, we are going to do exam questions, lots of exam questions based on this, because this is the hardest part of this topic, the immune system, the lymphocytes, the difference between antibodies and antigens. So in the next lesson, we're going to do lots of exam questions on that. So please make sure that you practice doing these questions to make sure that you fully understand it.